My name is Piltaver, and together with Janach, we'll present you this decision-making framework. So let's jump right into motivation, why we need it. If you imagine a web app, like a web shop, nowadays it will usually be implemented with microservices infrastructure architecture. So we'll have independent services. One will use to recommend products, one will show the data about the products, one will be for verifying payments, and so on. What this does is it makes development much more flexible. Now we can deploy, develop, and scale each of the services individually. But for operations, it makes things much more difficult. First, we must containerize each of these microservices. Then we need to deploy them. In this picture you saw we have over a dozen microservices. If each has 12 instances, it means we have to deploy 30 things. We have to monitor them and scale them. This is why we use orchestration systems like Kubernetes. These orchestration systems are not all the same. There are plenty of them, and they are very different. So in this use case, let's see two very different and why we need different systems. On one side, we'll use Azure Kubernetes service, and on the other side, K3s. This AKS is managed, it lives in Amazon's cloud. It simplifies a lot of DevOps work, but it requires more hardware, so it has high resource usage. On the other side, K3s is open source, it's self-managed, it can be deployed in a private data center. It requires more DevOps expertise, but it has minimal resource usage. So we want a system that will be able to tell us which of those two orchestration systems is the best, but not the best in overall. Which one is the best depends on the use case. So for this evaluation, we came up with three companies which want to use the systems, and our methodology must be able to tell us in which environment each of these orchestration systems is the best. So the first one is solo dev. This is just a single developer with limited experience, limited resources. So he wants low cost, he wants simple deployment, as little overhead as possible, but his users are not very demanding, so he has modest performance requirements. On the other side, we have CloudCore, a very successful software as a service company with good reputation, so they need to protect it with high availability, security, and the only limitation is that they work on cloud. And the third one will be On Metal. This is similar, a big company, SaaS company. Availability, security, performance are important for them, but they don't work in cloud. They have their own private data center, and they have very versatile, very strong DevOps team that has been working with this infrastructure for years. So now we need a model that will tell us which orchestration system is the best for each of these three use cases. So how we build the system? We didn't start from scratch. We said let's use DEXi. This is Decision Expert methodology for decision support systems, which is implemented in DEXi software. I won't take this sentence because it's too complex, but let's go step by step and explain what this DEXi methodology does. First, it's multi-criteria. So we're not looking only at one property of orchestration system, like performance. We can look at multiple at the same time. So for us, we said cost, the work to set up, and the work to then operate this system are the most important things. Then the other thing is it's hierarchical, which means that we can break down each of those properties into sub-properties. So what it does for us when we're deciding is it breaks a complex decision into multiple simple decisions. For example, we distribute this ops work into app deployment, monitoring, and scaling, how difficult it is to do each of them. Similarly, we can break down setup. Then what does qualitative mean? It means that when we're rating how good is scaling in one system, we don't say it's 7.5 on the scale from 0 to 10. We say it's unacceptable, acceptable, or good. Why such simple scale works better? Because it ensures consistency. Like it's very difficult to say for one system it's 5.2, for the other it's 5.3, and when we have 10 systems to compare, it's difficult to be consistent. Here it's very simple. Either it is so bad that it's unacceptable for us, either it's good enough that we say it's good, we like it, or it's good enough but not awesome. And finally, when we rate all of this, we have then to compare, to calculate the overall quality, and how we do it with rules. Which are the rules? Basically, we set up the rules, and they can be represented with a simple table. So we say if app deployment or monitoring or scaling is unacceptable, then the whole operations part is unacceptable. If two of them are good, then it's good. In our case, we have acceptable, good, and acceptable, which give us acceptable. And we have similar tables to calculate the setup and then the total overall quality. So for this system, we say it's good. If we have two systems, we rate them with this decision model. What we can do then, we have evaluations, we have ranking, which will tell us which system is better, and we can do very detailed comparisons and analysis like if-else analysis. What would happen if this wasn't unacceptable but acceptable? Then the model will tell us the both systems are good. So this is for my part. Now I'll invite Antonio to present how we applied this system and what are the results.
Yeah, thank you, Rok, for inviting me. So I will start from this slide and until I finish the whole presentation. So for a decision model application, we used 4 key attributes, and the first one is performance. Performance represents end user experience, including request latency and availability. It is important because it directly impacts on user satisfaction and it determines service capacity before scaling. And this attribute is objective and quantitative. For evaluation methodology, we used tools like Apache AB and the K6. With Apache AB, we measured homepage requests, and as alternative, we used a K6 to simulate the whole user experience. So on these two graphs, we can see that a K3S is better because lower the results here on the graph, it results the better result. So on our model, how this looks like, we can see that K3S scored better in all 3 business environments, except for a solo dev, AKS scored good. So for a solo dev, we can say that he doesn't really matter much about performance. For him, this is acceptable. Another attribute represents cost. It represents total cost of running the application with the orchestration tool. It includes hardware, infrastructure maintenance, electricity, networking, and data center expenses. It is important because it directly impacts on the profitability, and it is a key business concern for operational expenses. This attribute is also objective and quantitative. For evaluation methodology, we used Azure Total Cost of Ownership Calculator developed by Microsoft. So the scope was to compare on-premises K3S and the Azure Cloud AKS over a 5-year period. So here we can see estimated costs for a K3S 28K and a 14K without hardware cost included. For AKS we can see 16K in the term of cost. Here on our model we can see for a solo dev business environment that the K3S is unacceptable because you need to pay for initial hardware, servers, and equipment. For AKS, it is acceptable for him. For a cloud core, we can see that AKS scored better because they are running everything in cloud. For own metal business environment, K3S scored better. This is a quite opposite side from a cloud core because they are running the servers at their site, and it would be bad for them if they are not using those resources for these kind of workloads. System setup attribute, it represents a DevOps effort required before initial application deployment to production. This attribute is subjective and quantitative. Here we can see that AKS scored better, and the K3S scored better for our own metal business environment. We were based here on documentation, known processes, and team experience. So the master thesis was written and the whole research was done there. For a team experience, we got some DevOps teams that we got some knowledge from them. Operational work, this is a DevOps effort required after initial application deployment to production, and here we can see that AKS also scored better. For results and conclusion, for this use case, when we need to choose between K3S and AKS for a cloud core, we can clearly see that AKS scored better in 3 attributes. For this case scenario, we can see that in which business environment K3S scored better. We can see that it scored better on own metal. And conclusion, we showed you a decision-making framework for evaluating orchestrating systems, and we can now jump on the questions, but before, special thanks to SIG Mobilities for their resources and support. Thank you.
Thank you.